Okay, we will get started. Hello, friends. I would like to welcome all of you to our this monthly webinar. So this is a monthly webinar series. We have been doing it for last 1 year, right? This is for the engineers, by the engineers, and of the engineers. So we are going to get external speakers and come and talk to us about troubleshooting and performance engineering. And if any one of you have interesting stories and we want to share with the community, you're most welcome to let us know. We'll be glad. We can work with you to see whether if the content makes sense, we can have you be the speaker in one of our upcoming webinar series. Okay. Having said that, let's jump to today's topic, advanced heap dump analysis techniques. So friends, in this session, we are going to be talking about 7 techniques which we can use for doing heap dump analysis. So these, if someone is looking for basic heap dump analysis, like how to take a heap dump, how to analyze them, how to get to the root cause, right? You want to watch one of my earlier webinar, which is called as Common Memory Leaks in Java. The link for that is given here. So in that webinar, we talked about the basic techniques. Now we are going to be talking about advanced techniques, right? So even if you don't understand, you didn't watch the basic techniques, still it is okay. These advanced techniques will still be helpful for you. Okay. So having said that, let's move on. Okay, friends. In heap dump analysis, there are multiple challenges, right? One of the primary challenges, transmitting the heap dump file from your production server to your local machine. That is, what do you mean by that is, see, heap dump is a very large file, right? It's a very large size in nature. So how it's going to be given to your local machine, how it's going to come to your hand so that you can use your heap dump analyzer tool to make the analysis. See, friends, typically from a production server, it is a large file. So you cannot put it in email or you cannot send it, right? Because of size restriction. And sometimes there is even going to be firewall restrictions so that you cannot directly move from heap dumps from production server to your local machine. So typically, what is a practice we are seeing across the industry is your SRE engineer moves this heap dump from your production server and he puts in some shared drive, right? And sometimes if you're doing if your customer is sending you a heap dump, he's going to put it in some shared drive, right? And then from this shared drive, you are downloading this heap dump to your local machine, and then you are doing the analysis, right? And in case, let's say, your heap dump, you want to give it to your QA engineer or to a coworker to look into that. Then this heap dump file is once again going to that coworker's machine, right? He's going to download from the shared drive and is going to go to the coworker machine. So friends, if you see, heap dump is a sensitive information. It's classified as a confidential data because heap dump tends to contain whatever your application process. Our application processes credit card numbers, social security numbers, VAT numbers, right? Email, PAA data. There's going to be email address, phone numbers, and all those things are going to be there because it's a snapshot of your memory. So all those sensitive information is going to be present in your heap dump. But now, friends, look what has happened. Your heap dump is now in production server. It is now in the shared drive, and now it has come to your local machine. And now it has come to, if any other coworkers are going to analyze, it's going to go there as well. So your heap dump, the sensitive information artifact is now distributed in so many places. After analysis, are we deleting this heap dump? Question mark. We don't know. And then there is another challenge here. What is our next challenge is, okay, heap dump is a large file, and now you got it to your local machine. Does your local machine have sufficient memory to analyze the heap dump? See, your heap dump file is going to be more or less going to be the size of your XMX. Say, suppose your XMX, that is your heap size of your application, let's say is 10 gig, right? You set as XMX as 10 GB. That means your heap dump file size is also going to be roughly approximately 10 GB. To analyze this 10 GB of data, you need to have 20 GB of RAM. Roughly, you need 1.5 times to 2 times the size of a heap dump file. That's the amount of RAM you need. So let's say it's a 10 GB file. Do you have 20 gig RAM on your local laptop? But let's say if your XMX is even bigger, do you have sufficient, say your XMX is 20 gig, do you have 40 gig RAM on your local laptop to do the analysis, right? This is another challenge. So how we are going to address these challenges? So here we want to introduce you a technique. The technique is there is a REST API available to do the heap dump analysis, right? So using this REST API, friends, what you can do, look at this. Your production server is there, heap dump is there. You can trigger a REST API. I'll talk about it. When you trigger the REST API, the heap dump moves from your production server to heap hero server. That is our heap dump analysis tool. And then once the heap dump is here, it's in a heap server, it's a heap hero server. You can either install it on a local machine and do the analysis, or you can install it on some central server. You can install it on any EC2 instance or any containers. And then it's a web application, right? So it can run locally, or it can also run on the cloud. So once it is, say, on some EC2 instance, and if heap dump is here, just from your browser, you can connect and then you can do the analysis. So if your coworkers also want to do simultaneous analysis, they can also do analysis. The beautiful thing, there's two beautiful things is happening here. The number one thing is your heap dump is not getting distributed anywhere. The sensitive confidential information, in earlier case, it was there in production server, in the shared drive, in your local machines. Now it is not anywhere. It is just going to be stored only in one location in the heap hero server. And all of the engineers will only have access to the analyzed report. So no one has an access to this sensitive information, right? So this is a very secure way to do the analysis. So now let me show you how to invoke this REST API. Friends, it's a very simple curl command. You can find the details about this here. It's a simple HTTP post. That's all it is, right? Let's just do a demo. The documentation of that, you can find it here. So let's do a quick demo of it. See, this is the curl command I'm going to be using, right? This is my location of where my heap dump files is present on the local disk on my production server. So I'm going to be triggering this command from my production server. So here is the location of where my heap hero server is there. And then I can give any tag that whatever I want. Say, suppose let me tag it something like a webinar demo 2025. Okay. And now let me issue this command from my production server. So here is my production server. Here I have a heap dump in this location. So now so I'm going to be pasting this command, basically just a simple curl HTTP post. So now I'm doing it. Okay. So before I do, let me show you how does a Ycrash's heap hero dashboard is going to look like. So this is the dashboard. All right. So this is the dashboard. Currently, there is only two incidents are there. There is two dumps are only analyzed. So now let me trigger this API and let's see what happens. So now I'm coming here. This is my production server. From here I'm triggering. So when I triggered, what's going to happen is the heap dump is read. And now it's transmitted to the Ycrash server. Now the Ycrash server analyzes and sends you back a JSON response of all the details that you see in a typical heap dump analysis available here. You can either take this JSON and try to interpret, or it's going to be, see now if I'm going to, there has been only two incidents. Now let me refresh this. Now when I refreshed it, see I got a third incident reported. This is the newly heap dump that got pushed from my production server. You see why webinar demo 2025 is showing up here. So now when I come in here, I can now go to this heap section. So here is my heap dump analysis. Heap dump is present. So now from here, I can do the analysis. I can look into this, what are the objects, drill down and keep doing this. So now the beautiful thing, without exchanging hands, your data, your heap dump has been moved from your production server to your Ycrash server. And that too, since you're going to install this Heap server in a central machine, right? Say, suppose you're going to install an EC2 instance, which has a very beefy heap size, then you don't have to worry about whether your local laptop has sufficient memory capacity, because in EC2 instance we can allocate as much as we want during analysis time. So now I have the enough memory is there, so I can do all the analysis. And even if your coworkers want to connect, they can connect to that endpoint, and then they can do the analysis from their browser. Okay, friends. Now here there is a second option to address this challenge. Say how to take the data that is from a remote location. That is how to take a heap dump, which is from your production servers. So sometimes what happens is your SRE team is going to suppose your SRE team is going to put the heap dump in some shared drive. They can put it in some remote storages. They can put it in S3 buckets, right? They can put it in S3 buckets, or they can put it in some remote web servers. So what you can do, you can see here in this EPRO, there's a capability where you can give this S3 bucket URL or HTTPS URL here. When you give it here, what's going to happen is EPRO server will connect with that remote location and download the dumps and then present you the result. So here, once again, there's no exchange of heap dumps happens. EPRO connects with the remote location, downloads it, analyzes, and gives you the result. So now, yeah, this is what happens in this case. In this pull model, EPRO server goes to remote storage, downloads the heap dump, does the analysis, and presents you the result. Now, let's just look into this. So here, I have an heap dump present in an S3 bucket. See, here is an S3 bucket URL. You can see it is an S3 bucket URL. It's present. So now let me demonstrate this to you guys. See, here there is analyze heap dump. I'm coming here, and now I can paste any remote location. It can be S3 bucket, HTTP, HTTPS. And if you want to add any credentials, we can do. If you want to add any credentials, I can do, and then do analysis. So when I say analyze, now ePro server is going to go to the remote location, shared drive. It's going to download the dump, and then it's going to analyze and then present you the result. So since it's in a central EC2 instance, it's running on a central EC2 instance, anyone from your organization can do the analysis. They don't have to download and install the tool on the local machine. If they want, they can do, but here it's available. So they can drill down and see what's going on. Okay. So now there is another challenge that we often confront when doing heap dump analysis is heap dump tends to contain sensitive information, right? Because it is basically a snapshot of your memory. It contains social security numbers, credit card numbers, VAT numbers, PIA data. So when your developer downloads and then they try to analyze, all those data is going to be visible for them in clear text, right? Say, suppose now I'm drilling down the data structure. See here, whatever is in memory is going to be visible. Look at this, the phone number, what is the passwords, email address, all these sensitive information is going to be visible in clear text. Say now, there's two things here. Now your engineers can see, right? And then what if this heap dump falls into some wrong hands, right? We try to secure in every aspect, but what if this heap dump goes and lands into some wrong hands? If they're going to open up in any heap dump analyzer, they're going to see this data in clear text. See, that's why there is a heap dump sanitization capability that what you want to use. So what happens is when you turn on this heap dump sanitization capability, the EPRO tool, it will sanitize the data. It will investigate a heap dump, and then it will remove all the data from the heap dump. That is, instead of data is going to replace it with asterisk. Because as a developer, I don't need to see what is the actual raw data. I just want to know, okay, there's a data and what length it is, right? That's all I need to know. So when you turn on the heap dump sanitization capability, say this is how the user will see without a heap dump sanitization. When he turns it on, you can see it's going to be masked. It's not just masked in the report, it's just even the raw dump itself, it is removed, it is evicted. So even if the raw dump ends up with some wrong ants, they don't have any data with them. So this is a very secure way to do the heap dump analysis. Okay. So now I am moving along. See, friends, the next question, what I want to ask you is heap dumps sufficient to troubleshoot out of memory error? See, when we confront out of memory error, we take heap dumps. The question that what I have for you guys is heap dump sufficient enough to troubleshoot all sort of out of memory errors? For that brings a question, how many types of out of memory errors are there? How many types of out of memory errors are there? Friends, when I ask this question, when I tell the answer, people get surprised. Actually, there is 9 different types of out of memory error. It's not one type. There's 9 different types. So heap dump is not sufficient to diagnose all these 9 types of out of memory errors. So in fact, these are the different types of out of memory errors. So heap dump is needed only when you confront Java heap space and GC overhead limit exceeded. So only when you confront these 2 type of out of memory errors, you need heap dump. Of course, these are the 2 primary types that we often confront. But there are other types of out of memory error, like unable to create new native threads, meta space, permgen space, kill the process or sacrifice the child. Like these type of errors, when you get, heap dump is not going to be sufficient. When you get unable to create new native threads, I want to use thread dumps to see what it is. If I get meta space, I need to see verbose class loading log, right? I need different artifacts. So friends, how to troubleshoot all these 9 different type of out of memory error? We have here is a link, and we have made a webinar in the past on it. So you may want to go and look at this. Here is a link. You may want to take a look at it. Here we talk when we confront each type of out of memory error, what artifacts you need to capture, and how do you go about troubleshooting. You can find it in this blog post. But the quick answer is just heap dump is not enough to troubleshoot out of memory error. You need additional artifacts. So how do you get these artifacts? I don't know what error I'm going to get in production. So I may get any type of this out of memory error. So the best way to handle the situation is equip yourself with sufficient data. Equip yourself with all the data that is required to troubleshoot any type of out of memory error or in general any type of memory problems, right? To facilitate that, here there is an open source script, my friends. Here is an open source script which is called as a YC360 script. This is open source script. There's no licensing attached to it, anything like it's an Apache license. So what you can do when you can trigger the script like this, you can say YC, this is a script, -p and process side. It's a platform agnostic script. It can run on Linux, all flavors of Linux, Mac, Windows, Docker, Kubernetes, OpenShift. It can run on all platforms. So when you trigger the script, this script is going to capture you the 360-degree data. Right? Say it's capturing garbage collection log, thread dump, heap dump, demessage. In fact, it discovers application log is one of the very vital artifact to troubleshoot several problems. So it auto discovers what are the logs to which it writes. It scrapes last 10,000 lines. And then this script builds everything as one zip file. And then once you have the zip file, you can take it and can do the analysis. This zip file will facilitate you to troubleshoot almost all of the production problems that you encounter, which goes beyond out of memory error. You can troubleshoot all type of out of memory errors or any performance problems you can troubleshoot with this script. So you may consider leveraging this script. See friends, and another interesting thing that what you want to share, we don't know when the out of memory error is going to happen. See, one of the common challenge that we face when we troubleshoot out of memory error is we don't know when it's going to happen. And also the very important thing is you need to capture this diagnostic artifacts like heap dumps or GC log when the problem is happening, right? See, when the application is healthy, when you capture it's not going to be helpful. But let's say when the problem has happened, because when the problem happens because of the heat of the moment, our SRE team they go and recycle the JVM, or they automated it so that the JVM gets recycled. If it gets recycled, we don't have the data. See, just like when you go to a doctor draws blood samples, urine samples from your body, but that needs to be drawn when you are sick, right? So here is a very handy approach. To JVM, you can pass an argument called XX, on out of memory error. So what you're telling to JVM is on out of memory error. When out of memory error happens, if you configure this YC360 script, then you're asking the JVM to trigger the script when the problem happens, whenever you confront out of memory error. When you confront out of memory error, and when you trigger this script is going to take the 360-degree data and then bundle them up and have the data available for you, which is so wonderful. So you don't have to worry when it's going to happen. So once you have the data, we can go ahead and we can analyze it, right? Okay. See, friends, the next the next challenge, what we face often is why memory problems are not caught in the performance lab. Why memory problems happens only in production. Aren't we seeing it in our performance labs or in our early testing in a pre-prod environments? Why it happens only in production? Friends, there are reasons, right? Why the memory problems often surface only in performance lab. What are they? Friends, one of the primary reason is in our performance labs, we use synthetic data, which is not modeling the production data. See, for example, I want to give you an example. I used to work for a very large bank in North America. It's a very large bank. See, typically a customer has a 2.5 accounts. So that is average. A customer will have 2.5 accounts. So in our performance lab, we model our test data with that 2.5 accounts. But there are exceptions. Say, there are certain customers, when they do have like a 250 accounts, who have 300 accounts. Yes, some customers do have. When a customer who has like a 300 accounts, when he signs in, he's going to stress several aspects of the application. Whether do we have enough number of connections in the connection pool? Whether do we have enough number of threads to make 300 backend calls, right? When we get the data back, do we have enough memory? So it's going to stress several aspects. And what if two such customers come at the same time? We don't model those kind of things in our test environment, but they do happen in production, right? And the next reason is our performance environment is not same as production environment. The infrastructure wise, the number of CPU cores, the RAM size, even sometimes the kernel settings, the kernel patches, they're not identical, right? They are different. That's also another reason. And the third reason is, friends, a lot of times the memory problem surfaces only when your application runs for a long period, right? Say for out of memory to happen, sometimes it may take several days. For several days, it has to build up, and then you're going to get out of memory error. Whereas in our performance labs, probably we are running a short duration test, a 1 hour, 2 hour test. Some organizations I have seen, they run an endurance test, that too, but it's for 24 hours. But what if your memory leak is happening after 48 hours or 72 hours? It goes unnoticed. And then next reason is there is an absence of real world chaos. See, in production, suddenly there could be a load balancer can go bad. There could be a network contention. A backend can become unresponsive. We are not simulating all such scenarios in our performance lab. When that happens, the problem happens, right? So friends, these are all very valid reasons. Agreed, right? That's why we're not able to catch the memory problems in the performance lab. But friends, I still want to say these production problems, these memory problems do happen in our performance lab. They do happen. But they do happen at an acute scale. They do happen at a small scale, which is not big enough to catch our attention, right? There's a small memory arbitrations happen, but it doesn't catch our attention because in our performance labs, we monitor only the macro metrics. What we monitor in our performance labs, we look at primarily, we look at the response time, 99% response time. We look at the memory. What is the memory utilization? What is the CPU utilization? These are I'm calling classifying them as macrometrics. These macrometrics are not good enough to capture minor arbitrations. So these minor arbitrations are what manifesting in production as major outages. Say, to catch it minor arbitrations, you need to be monitoring micrometrics in your performance lab. What are those micrometrics? Friends, actually, there are 9 different micrometrics what you want to be monitoring in your performance lab. So these are those 9 metrics. The details about them, you can find it in this earlier talk. You can go over there and take a look at it. But I'll just talk about one important metric in this session, which is the garbage collection behavior pattern. That is, what is garbage collection behavior pattern? Let's look into this. See, friends, this is actually, this is a GC behavior, a garbage collection behavior of an healthy application. See, why do I say healthy application? You can see the request is coming, the memory is building up. When a full garbage collection event runs, the memory drops all the way to the bottom. And once again, the request is coming, the memory is building up, and a full garbage collection event runs, the memory drops all the way to the bottom. You see this beautiful sawtooth pattern, memory going up and down, up and down. If I try to draw a line connecting all the bottom points, you see this is a black arrow. It goes at a 0 degrees. It's going almost at a 0 degrees. You can see it's almost going at a 0 degrees. Now, look at this, my friends. So this is the garbage collection behavior of an application which is suffering from out of memory error in production environment. Look at this, what's happening. You can see the memory went, when the garbage collection went ran, it dropped. Memory went up, when garbage collection went ran, it dropped. But you see, as time is progressing, the memory is climbing up. And now here, the garbage collection is keep on running. The rectangles means the full garbage collection and keeps on running, but the memory doesn't come down at all. We get out of memory error. The JVM throws out of memory error when we reach the ceiling limit. When we reach the ceiling limit, the problem happens. But friends, look at this. In our performance lab, probably we are running only the test for initial few hours, couple of hours. At that point, this is what you see. Look at what you're going to see in the performance lab is what is before the red line. Okay, you see it is going up. But we don't see this one happen. This one happens when we run only a long duration test, which is what out of minute typically happens in that kind of situation. So what you want to do in your performance lab is you want to be looking at the garbage collection trend. Oh, I see. Okay, now if I try to do a slope connecting all the bottom points, here it is not going at a 0 degrees like in the previous example. It's going at an inclination of 20 degrees. If it is going at this kind of an inclination, 20-degree slope, it means this application is having an acute memory leak. And if this application continues to run, it's going to bomb like this in production. So like this, there are various micrometrics. These are micrometrics. You want to be looking at them so that we can predict and forecast production outages in your performance lab as well. Details on how to source all these metrics, what tools you want to use is available here in this link, right? You can look into that. Okay, friends, the next advanced technique that I want to share with you is object query language, OQL. See, just like how we have SQL, structured query language, to query our RDBMS system, database systems, OQL also has its own syntax, right? It has a select, from, where, group, filter, all these expressions are available, right? So for now, let's just, I'll show you how to use this SQL. Here is a very basic SQL, right? Say, if I'm going to say select star from this string object. So this is going to retrieve all the string objects which is there in my heap dump. So now how do I trigger it? So now let's say this is my heap dump analysis report. Here is this OQL. If you come down, here is OQL. So here I can paste this SQL, OQL. Select star from Java lang string. When I execute it, I'm going to be seeing all the string objects which is there in the memory. Oh, look at this. There is one string. So if I click here, I can see what is that value. So here, okay, see this is it has the value XXX, right? I can see this. And say, suppose I want to add some var condition. Say, I want to see all the string objects which are greater than, say, suppose, see here I see there are some small string objects also. There's one string which is 24 bytes, but there are other string which is 10 MB, right? In the retained equal. Say, suppose I want to filter and I want to see only the strings which is greater than 5 MB in size. Then what I need to do, select from string where the retained heap size is greater than 5 MB. That's 524 kilobytes. So now when I'm going to execute this, I'm going to see, so I execute it, I'm going to see only the result strings which are greater than 5 MB in size. So it shows me all the objects. If you want to see what those objects are, I can see them here. And say if I want to see who is referencing the string object, I can click on this more icon and see what are the incoming references, who is referencing the string object. Okay, so then I can see, okay, the string object is referenced in this class. Who is referencing this class? Okay, it is this one. So I can walk through the tree to see the reference hierarchy. Okay, so to learn more about this OQL syntax, what are the clauses available, what are the filter criteria, what are the keywords available, you may want to go into this link which is given here. Okay, so now friends, the next important interesting thing that I want to share is heap dumps are a little bit complex, right? It's you can look at them from a table structure, right? What are the biggest objects? You can look at it from a table structure. But if there can be a graphical visualization, it can be a little bit more easier to visualize what's going on in the memory. So to do that, there is a sunburst chart visualization is available where you can visualize the objects which is there in the memory. So let's look into that. So here, see here is my report. Here I have this chart. Yeah, so here is my chart view. So when I click here, I get to see what are the biggest objects which is there in the memory. So now I can see in my memory, there is an object called as a Java Lang Ref Finalizer. It is occupying 95% of memory. You see, that's why this pie is very big. It's occupying 95% of the memory. So what is, so if you want to see what does this object contain, what are the children of this? So when I click here, I get to see the children of it. So here it contains a child which is 440 MB. And now if I click here, okay, I can see, okay, what are the child elements? So here there is one finalizer object which is occupying 10 MB. There is another object which is occupying 10 MB. I can see like this. What are the other objects which is there? So when I move around, we can see, look at this, the values here are also changing. Based on the object that I'm selecting, the values here, you can investigate what is the value here, then you can look at it. And say, suppose if you want to go back one level, or if you go back to the root level, I can do this home and I can go back. Okay. So yes. Okay. So friends, with this, I'm coming to the end of my session, right? But I'm going to be here to take any questions that you're going to be asking. If you have any questions, please feel free to ask. I'm going to be responding right now. And friends, in case if you're not bored with this session and you want to learn more about JVM troubleshooting and performance engineering, you may want to go to this link. It has an online JVM performance masterclass. So you can register for this and then you can attend. It has like a 8 to 9 hours of content. You can watch at your free time, and there's exercises that you can do, and which may facilitate you to get a little bit more, which may facilitate you to get deeper knowledge on JVM performance and troubleshooting. Okay, thank you, my friends, for attending this month's webinar, and this deck will be published in this Ycrash blog.